You are most welcome to this episode where we shall be looking at trigonometry. We shall start with sine, cosine, and tangent. Trigonometry is a branch of mathematics that deals with the relationship between the length of the sides of a triangle and its angles. So basically we shall look at the meaning of sine, cosine, and tangent. Let us start with the right-angled triangle. A right-angled triangle is a triangle whose one of the angles is 90 degrees. Any triangle with one of the angles 90 degrees is a right-angled triangle. Assuming we have our triangle ABC, angle B is 90 degrees. Therefore, this is a right-angled triangle. Angle A is an acute angle, meaning is less than 90. We have the sides of triangle ABC, whereby the base of the angle, or where the angle sits, the acute angle sits, that is angle A, is what we call the adjacent. And where it faces, where angle A is facing, is the opposite. And the longest side is the hypotenuse. So on a right-angled triangle, we have three sides. That is the adjacent, the opposite, and the hypotenuse. How do we name this? It is not by guessing. Where our angle faces is the opposite, the acute angle. It could be angle A, or we could also take angle C. So in case we are considering angle C, the adjacent could be the opposite, and the opposite could be the adjacent. That is if we are considering angle C. But the hypotenuse remains because it is the longest side of the triangle. So the longest side SC is our hypotenuse, and then side BC, which is opposite to our angle A, is the opposite, and the AB, which is adjacent to our angle, is the adjacent. Therefore, we connect this with our three ratios, that was sine, cosine, and tangent. The ratio of side BC to SC gives us the sine of angle A. We have BC, that was our opposite, SC was the hypotenuse. So meaning that the ratio of the opposite and hypotenuse gives us the sine of the angle, meaning that sine A equals to opposite over hypotenuse. Then the ratio of AB to SC gives us the cosine. So the cosine of angle A is given by the ratio of AB, which is the adjacent, to AC, which is the hypotenuse, meaning that cosine of A is equal to adjacent over hypotenuse. Then the tangent of angle A is given by the ratio of BC, that is the opposite, over AB, the adjacent. Simply meaning that tan of angle A is equal to opposite over adjacent. To summarize this, we've seen sine A as opposite over hypotenuse. Cosine A is adjacent over hypotenuse, and tan A is opposite over adjacent. That is how we shall define those ratios in connection with our right-angled triangle. So, the sine, cosine, and tangent are abbreviated. We abbreviate sine as sine or sin. The cosine is abbreviated as cos, and the tangent is abbreviated as tan. So when I say sine A, I mean the sine of A. When I say cos A, I mean the cosine of angle A. And when I say tan A, I mean the tangent of angle A. And we've seen that sine A equals to opposite over hypotenuse, then cos A equals to adjacent over hypotenuse, and tan A equals to opposite over adjacent. So that is how we define those three ratios. But we have the relationship between these three. If we consider a right-angled triangle with our acute angle theta, hypotenuse R, opposite S, and the adjacent C. From the definitions of sine, cos, and tangent, we saw that sine equals to opposite over hypotenuse, meaning sine theta equals to S over R. And therefore, when we make S the subject, we shall have S equals to R sine theta. Still, we saw that cos or cosine of theta is given by the adjacent, which is C over hypotenuse R, which gives us C as R cos theta. And the tan of theta equals to opposite S over the adjacent C. So when we make S the subject, we shall come up with the S equals to, we already have S, which is R sine theta. We also have C, which is R cos theta. So when we substitute in this formula, we shall get our tan as R sine theta over R cos theta. Since R is common, it cancels out to give us tan as sine theta over cos theta. So that is the relationship that connects the three, meaning that tan equals to sine over cos. Let's look at examples. In our example, we are considering a triangle ABC, where AB is 3 centimeters and BC is 2 centimeters. We are also given angle theta. We are supposed to find tan theta, sine theta, and cos theta. We've seen that tan theta is given by opposite over adjacent. So if we look at our triangle, the opposite to the angle theta is 2, and the adjacent is a 3. So when we substitute in the formula for tan, which is opposite BC over the adjacent AB, so the opposite is 2 and the adjacent is 3. So it gives us tan as 0.67. Then for sine, for us to find the sine, we must find the hypotenuse first, because we saw that sine equals to opposite over hypotenuse. Therefore, we cannot find the sine when we don't have the hypotenuse. But when we are to find the hypotenuse, we shall bring in what we call the Pythagoras theorem, which says that the longest side is equivalent to the square root of opposite squared plus adjacent squared. Or we can also say that AC squared equals to AB squared plus BC squared. Then we substitute. This is what we mean using the Pythagoras theorem, which is AC squared equaling to BC squared plus AB squared. But we have BC and AB. BC is our opposite and it is 2. AC is the adjacent, AB is the adjacent and it is 3. So we substitute and simplify to find AC, which is 3.61 centimeters. After getting AC, we can now substitute in the formula for sine, which is opposite over hypotenuse, to get its answer. The same applies to cos, because cos equals to adjacent over hypotenuse, but the adjacent is a 3 now. So it is 3 over 3.61 to give us 0.83 as our value for cos. In our next example, we are supposed to find the length indicated as x. But according to our figure given, we have the angle 35 degrees and 4 is the opposite, because it is where the angle is facing. So in this, XC is the adjacent to the angle. So when we want to find x, we must first of all determine which of the 3 ratios connect the angle of 35 to the opposite and adjacent. Probably that is the tangent. So we shall say tan of 35 equals to opposite 4 over adjacent, which is x. And therefore, when we get tan 35 equaling to 4 over x, we cross multiply and divide by the tan of 35 to find the value of x. So x is 5.71. Still, if we continue to our next example, it says find the values of x and y in the figure below, and we are supposed to collect to two significant figures. We are given the diagram, and you realize that this is a right angled triangle because one of its angles is 90 degrees. So we are given one of the angles, that is 33.2 degrees, and if we consider this angle, you realize that x is the adjacent and y is the opposite. Then 8 is probably the hypotenuse. So we are supposed to find x and y, but we must know what connects these unknowns to the known ones. For instance, sine of 33.2 is opposite, which is y, over hypotenuse, which is 8, meaning that we shall have sine of 33.2 equaling to y over 8. Then we cross multiply by 8 to get the value of y, which is 8 sine 33.2, which will give us a 4.4. Still, to get the value of x, remember x was our adjacent. So what connects the adjacent, the angle given, and the hypotenuse? Probably that is cos, whereby cos of the angle equals to the adjacent of hypotenuse. And therefore, when we substitute, our angle is 33.2, the adjacent is x, the hypotenuse is 8. So when we multiply throughout by 8, we shall come up with x as 6.7. Remember, we are collecting to two significant figures. In this example, we are given sine theta, tan theta. We are supposed to find cos theta without using a calculator. Remember, we saw the relationship between the three, whereby we came to a conclusion that tan theta equals to sine theta over cos theta. Since we have sine theta and cos theta, then we can substitute to get the cos theta. Still, we could also make cos the subject, because if we have tan theta equals to sine theta over cos theta, then we can make a cos the subject. That is, we can cross multiply, and then after that it gives us cos theta tan theta equaling to sine theta, and then we divide by tan theta to give us cos theta as sine theta over tan theta. where we substitute for sine and tan to find cos theta as 4/5. That is that is method 1, but we can also do it the other way around. We know that sine theta equals to opposite over hypotenuse, and tan theta equals to opposite over adjacent, meaning we can draw our triangle and indicate this. So from sine theta equaling to 3/5, it means that 3 is the opposite and 5 is the hypotenuse. The same applies to tan. It means that 3, we've already got 3 as our opposite, but 4 will be our adjacent. So after allocating the adjacent, opposite and hypotenuse, we can now find cos, because we very well know that cos equals to adjacent over hypotenuse. So the adjacent is 4, the hypotenuse is 5. So we simply pick up from the diagram to give us cos theta.